Welcome to the another video of data structures using Java. We have started with the sorting algorithms and completed two algorithms, that is bubble sort and insertion sort. In this video, we will be looking at insertion sort. So there are two things I want to discuss in this video. First one is working of insertion sort, and then we will go on for implementation of insertion sort. So I highly recommend you to watch this video till end so that you can get a clear idea. So before we start with the actual implementation of insertion sort, let's identify the things which is relatable to the insertion sort. We know that at least everyone has played a game of cards, and let's suppose you have 3 cards in your hand and the number on it 1, 4 and I have 8. Now let's suppose if any other card comes in which has a number, let's suppose 3. Now these are the cards which are present in your hand, and this is the newly arrived card. Now where you can place this card? We need to maintain the perfect order of this card. So what we basically do is we take this 3 and compare with this 8. 8 is greater than 3, so simply we move ahead, and again I have 3 over here. Is I will compare this 3 with 4. Okay, 4 is greater than 3, so simply I will come over here. Now my 3 is present over here, and I will check, is my 3 less than 1? No, which means I found the correct position for card number 3, and I have maintained a perfect order of the cards in my hand, that is in increasing order. This is how exactly the insertion sort basically works. So what does insertion sort says that I want to divide my array into 2 categories. It simply divides my array into 2 categories. So the first category is divided under sorted part, and second is comes under unsorted part. But observe carefully over here is that my first element is assumed to be sorted. In selection sort, we assume that nothing is sorted at first. But in insertion sort, we are assuming that my first element is already at its correct position. Okay, then what we basically do is we start with my second element and try to check, is there any element to the left of my 1 and greater than 1. Understood what I said? That I am starting with 1 and I will go on comparing the elements to the left of my 1, and if I get any element which is greater than 1, I will simply move that element to the right side. So let's get some dry run for this. So I have the array as 4, 1, 5, 3 and 2. What we did is we simply assume that my first element is sorted and this is nothing but unsorted. So currently my num has 1. So what basically we do is we check to the right of my 1, that is there an element which is greater than 1? Yes, right, the 4 is already greater than 1. So what basically we will do is we will simply move this 4 to the right side. So what my array will look like, it would like 4, 5, 3 and 2. Now there is an empty space because the 4 has transferred to the right side. Now there is no any element to the left of the empty space to compare with 1, so simply I will put 1 over here. Now I am done with the first pass. Then I will go to this next pass, 1, 4, 5, 3 and 2. If you observe carefully, in first pass I assume that 1 element is sorted, so in next pass automatically my 2 elements will come under sorted category and the remaining 2 will be in unsorted. Now again I am starting with the 5, so my num is currently contained element as 5. Now I will go on checking to the left of my 5, that is there any element which is greater than 5? No, nothing is greater than 5, so simply my 5 will remain at its correct position. So now I will go on to my next iteration, 1, 4, 5, 3 and 2. Now the total 3 elements comes under sorting and remaining 2 comes under unsorted category. Now what I will do is I will start with 3. So my num contains 3. Now keep on checking to the left of my 3, that is there an element which is greater than 3, If it is, we need to transfer those elements to the right of side so that I can bring my 3 to its original position. I can see that 5 is greater than 3, so simply I need to transfer 5 to the right side. So 1, 4, I got empty space, 5 and 2. Now can I put my 3 directly in this position? No, because there is a greater element which is greater than 3. So simply I need to transfer 4 to the right side. So 1 empty space, 4, 5 and 2. Now can I put my 3 over here? Yes, because 1 is less than 3, so simply I can put 3 at its correct position. So in third iteration I got the 4 elements to be sorted. So let's move on to the next iteration, 1, 3, 4, 5 and 2. Now there are 4 elements which comes under the sorted part, and the remaining 1 mainly comes under unsorted part. Now I will start from the element 2, so my num will contain element as 2. And what I will do is I will keep on comparing to the left of my 2, that is there an element which is greater than 2. So I found 5, so I will move to the right side. So come at 1, 3, 4, empty space, 5. Now can I put my 2 directly over here? No, because still I have the greater element to the left of 2. So I will simply move to the right side. So empty space, 4 and 5. Now can I put 2 directly over here? No, because still I have greater element. So I will simply need to move to its right side. And now can I put my 2 over here? Yes, because 1 is not greater than 2, so my 2 will come at its correct position. Now at the end, if you try to observe over here, is that my array is completely sorted, which means all the left part is contained under the sorted part and the right part comes under unsorted part where I don't have any element. So this is how exactly the insertion sort works. So I hope so that you got at least the central idea what exactly we are trying to do. We are going on checking with every element and trying to move to its left side if and only if I get any element to the left of it which is greater than this. If it is, we simply move this greater element to the right side so that we can bring this smaller element to left side. So let's get the pseudocode for this. So simply what we are doing is we are running the outer loop, right? that is moving from first element till the last element. Why I am considering the first element? Because we discussed earlier that insertion sort assumes that the first element is already sorted. That is the reason why I am starting with the element present at the first index. So my I equals to 1, I is less than n, I plus plus. And what we did is we took every element at ith index into the num, and we took the previous element because we are taking from its previous element, right? If I am standing at 2, I am checking to the left of it if there is any element which is greater than 2. That is the reason why I simply mark previous as I minus 2, because I want to move to the left side. I will simply write into the comment move left side. And now I will keep on running till my previous is greater than equal to 0, right? Because I need to go till 0th index, and what I need to make sure, if a of previous is greater than num, right? If any number to the left side, right? Any number to the left side of the current num, then I need to simply move to its right side. So if it is, what we basically do is a of previous plus 1 will contain a of previous, because we are shifting that element to the right side, and we simply do previous minus minus. Now once I come out of this loop, what is exactly happening? See, I was present over here, right? And I compared this to, that is element present at num index, with this 1, but this element is smaller, so this condition will become false. I will come out of loop. Now I want to place the element over here, but my previous is present at index 1, my previous is present at index 0. I want to place the element at index 1. So I need to swap this element at previous plus 1. So I will do int of previous plus 1 equals to num. So this is how exactly the insertion sort mainly works. What we are doing is we are running loop from the first element till last element, and for every element we are checking is there any element to the left of it which is greater than it. If it is, we are simply moving that element to its right side. This is what we did. A previous element is shifting to the previous plus 1, and we are simply going back till I get a final element, right? So this is exactly the implementation of insertion sort. Now let's go on to the IDE and try to check the implementation of this code. Now here I have implemented the insertion sort. Basically what I did is I simply declared the array of size 7, and as discussed, I am running loop from index 1 till size, and I took every element into my num, and previous is marked as index minus 1, that is current element minus 1, because we are moving to the left side, right? We are moving to the left side, and what we do it is from until unless my previous is greater than equal to 0, and if I get any element which is greater than my num, I am simply moving that element to the right side, and I did previous minus minus, and as we discussed that I need to push this element at previous plus 1 index, and finally we printed the array. So this is exactly the working of insertion sort. Now what will be the total time complexity for this? The outer loop will run for big of m time, so simply I will write here big of n time, and the inner loop, in worst case, it will also run in big of n time. Therefore total time complexity would be big of n square, big of n into en. So this will be my total time complexity of my code. So I hope so you understood clearly the working of insertion sort. Just in case if you are new to the channel, do subscribe the channel for more such information video.